Now we will move on to exercise E1-2. Also about the magnetic circuit. As you can see in my left hand side here, let me just read the question first. The magnetic structure of a synchronous machine is shown schematically in figure E1-2, this figure, right? Okay, assuming that rotor and stator iron have infinite permeability, yeah, for the rotor iron. So the rotor and stator is made of iron, which has the infinite permeability, meaning that mu r is infinite. Mu r is infinite. Find the air gap flux phi and flux density Bg. For this example, given that the current that passing through this winding of the rotor, which is 10 ampere, given also the number of turns of 1000, and gap G is 1 cm, and AG, surface area of the gap, is 2000 cm square. So first thing first, what we do is to do some sketch so that we can get the clear picture of this question, right? Let me just start with drawing this representation of machines actually. So this is the synchronous machine, which is, it should have stator and rotor. The outside one is stator, the inside core is the rotor part. So we have this, the inside which is rotor, the outside is stator. Okay, let me just write, this is stator and this is rotor. Okay, and it has the air gap, which is, AG, the same as the other one. It's also AG. And the permeability of the air gap, which is mu naught. Pole face surface area, AG. Pole face surface area, AG. The gap is 1 cm. Okay, the gap is 1 cm. G, the gap G is 1 cm. You can see also some magnetic lines. Oops. You can see also some magnetic lines, some different color. The magnetic lines or flux. And then this particular machine I don't have more colors, but just two black one. So we have wire winding. Okay, supplied by current I, and it has n turns, n number of turns. So that's all the information given. Given also mu r for this core is approaching infinity. We have infinite number of mu. So we can just write down all the information here. Given that current I is 10 ampere, right? Number of turns is 1000. Gap 1 cm. Convert it to meter, 0.01 meter. Can you see that meter? M, just M here. Okay. And then AG, surface area of the air gap, given that 2000 cm square. So I just shortcut it. Convert to meter square, you get 0.2. 2000 cm square convert to meter square, 0.2 meter square. So we want to find phi, which is in the question. Find the air gap flux and flux density Bg. So we are going to find flux first, phi first. So we use the equation for phi. For phi here, you know that phi is F divided by R. Okay, phi is F divided by R, and F is Ni. Okay, F is Ni. So I rearrange it like that. So this R is actually, this R is total R, which is the summation of RC plus RG. Okay, gap and core punya R. Okay. So if you remember in our previous question, so this is RC and this is RG, right? So the total reluctances, this is R tot, betul kan? Okay. So in this machine or synchronous machine, what is RC? RC is LC divided by mu AC. This mu is mu R mu naught. So LC divided by, where is my, I should write it. This is my border. So RC becomes LC divided by mu R mu naught AC. Okay. Which is, this mu is the core punya mu. Core punya permeability. Okay. How about RG? Which is G by mu naught AG lah. Okay. Dan ni saya dah explain tadi ya. Kenapa mu naught? Kenapa mu naught? Because in vacuum mu R is 1. Kenapa mu naught? Because mu air, udara, adalah mu R mu naught. Okay. Relative permeability times vacuum punya permeability. But in that case, mu R is 1. So mu air becomes mu naught, sama. So that's why we have mu naught. Let's say in the question, if mu core is approaching infinity, in this case, RC, from this formula, RC is LC divided mu core kan? mu core AC kan. If this guy approaching infinity, what happened to this RC? If this guy approaching infinity, something divided by infinity, meaning that RC equals to 0, that we can just neglect RC. Okay, so for our total reluctances, so for our in this case, it is RC plus RG. So this machine is actually dominated by reluctances of the air gap. So meaning that this is 0. Okay, so our is RG in this case. So moving on to the equation just now. Moving on to the equation that we want to find phi F by R, okay, equals to Ni times 1 over R. So this R is dominated by, this R is R total, but it is dominated by RG ya. Itu maksudnya. Bila permeability tu approaching 0, okay, boleh buka buku Fitzgerald. Saya tak kongsi lagi, nanti saya kongsikan. Okay, so we can just mana dah tadi, phi equals to Ni 1 over R. So phi equals to Ni 1 over Rg lah. Dia akan jadi Rg sebenarnya. Jadi for that Rg, it is G divided by mu naught Ag kan. So this equation becomes like this, divided by G. So phi equals to Ni mu naught Ag divided by G. But in this case, so we have for stator, we have rotor. So we have, this is G and this is another G. So how many G we have? We have 2G, okay? So in this case, it's 2G. So once we rearrange the equations, we can just find flux by substitute all the values given. N equals to 1000. I is 10 ampere. Right? And mu naught is 4 pi 10 7. Ag is 0.2 divided by 2G. Yeah? 2G, 1G is 0.01. 2G means 0.02. Let's just quickly have a check on each of the values. 1000, 10, 0.2, 0.02. We have 1000, 10, 0.2. G is 2G, 0.02. So betul lah semua, okay? Okay. Padam balik. Right. Borderline is here. Okay, so just using your calculator, so that I just shortcut it. Just quickly write it. The answer 0.13 Weber for the flux. 0.13 Weber of the flux passing through this core, okay, and also this air gap. Alright. So what else? We have another question in this E1-2. Another, other than flux, we want to find the flux density Bg. So for the flux density Bg, it just simply, let's say this is B. We want to find Bg. You remember phi equals to Ba, right? So in this case, we have already got the flux, which is 0.13 Weber divided by Ag. So 0.13 divided by Ag, which is Ag is 0.2. Then we have 0.65. Unit is Tesla for magnetic flux density. So remember the unit for the flux phi is in Weber. For the magnetic flux density is in Tesla. Nikola Tesla punya, Nikola Tesla, which is Tesla car. Viral now, Tony Fernandez, dia beli Tesla car, dia selfie. Lepas tu orang semua kecam dia. Okay. Right. So we have finished 1-2. I hope that we can 1.3 or E1-3 we have already, we didn't discuss in this session, in this with you guys. I didn't discuss this with you guys, but actually I have the answer attached to the Google Sites for E1-3 for this question. For this particular question, I have already shared the lecture notes or handwriting notes discussing this question. So I would like to proceed to 1.4 or 1-4, which is referring to this question. Okay, let me just end this session for this particular, the previous question. Okay, this session is not finished yet, yeah.